or something.
Presentation
Just
of
make sure I got your name right.
AHSP 2017. The speaker this morning is John Sojka. He's leading into a series of talks today on astrophotography. This has sort of become our astrophotography specialty day. John has a wide-ranging talk about how to get started in astrophotography, from simple to more complex, trying to make it easy for people to feel that they can do it. Not necessarily as well as the best astrophotographers, but at least take some pictures that you can be proud of and show that you're making use of your expertise, your equipment, your knowledge of the night. John's a worker within the defense and intelligence community. He's had the opportunity to work on various remote sensing missions, including the LaCrosse mission to the moon. So he's developed a lot of both professional and amateur expertise in taking pictures of difficult targets. With that, I'll introduce John.
Thank you. Thank you very much. Well, first of all, I'd like to thank all of you for being here, because it is 9:30 following a night of astronomy. Let's get going through this. We went through this. I always like to start with this slide about what people think an astronomer is, and what your friends think, what your mom thinks. There's a little laser point. What society thinks you do, and what we really do while we're out there. And I'm sure that we experienced this last night. This particular brief, what I decided to do was, I was asked to create one for the beginner, and as I worked through this, I decided to make it like, I remember in grade school when you opened up the first page of your math book, because you were curious at the start of the year, how hard is this math class going to be? So you'd open the first page, and it seemed pretty easy, but by the time you got to the last chapter, it was like quadratic equations and looked really tough. So what's going to happen in this brief is it's going to start really easy, and you're probably going to sit there and go, oh my God, I'm going to sit through this. It's too simple for me, but it's going to gradually get more and more complicated. So I'm trying to address a range of expertise. Next slide. So this is just one. I'm not going to read these all to you. There's just the first couple ones that I'm going to read to you so that they really hit home about what a photograph is. It is a photo. A photo is an image created by light, photons, falling onto a light-sensitive surface like film or a CCD or a CMOS camera, which are both types of chips that go into your modern-day cameras. So let's just get that out of the way. So it is an image created by photons. Next slide. The three most important things, and I am going to read these to you because I want them to stick. This is what you care about. If you got a camera and you want to get started in nighttime photography or astrophotography, these are the three things you care about the most. You care about your shutter speed, your ISO setting, and your aperture. So you care about the length of time that your film or your sensor is, sorry, I'm going to use this like Dr. Reynolds did. It's the shutter speed is how long the sensor inside the camera is exposed to light for fractions of a second to seconds and sometimes minutes, as we're going to learn. ISO is the sensitivity of the image sensor to light. It increases the sensor gain by multiplying the photons captured by ISO number divided by 100. And we're going to see how that comes into play in a few moments. Your aperture, the amount of light allowed through the lens to the sensor controlled by a diaphragm. Open it fully by selecting your lowest f-stop. So when you're going to go out and do nighttime photography and astrophotography, you want to capture light fast and quickly. You have no reason to keep your aperture real tight and small. You want to open it right up. Unless you want to sit there for longer. It's up to you. This is probably the last thing that I am going to read to you. So what is light? Light is electromagnetic radiation within a certain portion of the electromagnetic spectrum. The word usually refers to visible light that we can see. Of course, there's IR and there's UV. That's visible to the human eye and is responsible for the sense of that we call sight. And then I basically give the wavelengths from 400 to 700 nanometers. I just find this interesting, but we all know that that's okay. We have rods and cones in our eyes, and I think by now we know that rods are for dim light and cones are to capture color. But inside cones, you're able to capture red, green, and blue, okay, which is three different colors. But how many know the animal that has the most photocytes in their eyes for different colors? Does anybody know? The mantis shrimp has 16 photoelectric cells capturing different types of light. And it's been said that they can capture UV light and even polarized light. So they're doing experiments in that. So although we see this light, they see things in purple. And I think that butterflies see in 5 and dogs see in 2, which is what kind of makes them colorblind. But at the end of the day, what's light? Is it a ray? We ask ourselves. Is it a frequency? We all know that you can record light at frequencies, right? It's a wave. Is it a bunch of tiny subatomic particles? But what is light? What's the answer? Who's got the answer? It's photons. So great answer. There you go. It's all the above. It travels in little packets called photons that contain the properties of all these. And that's what's called quantum wave particle duality. You can measure it as a particle. You can measure it as a light. As a particle or a wave. And cameras collect photons. So the backbone of this brief today is this. Photons. When you walk outside, I just want you to think in photons from now on. So when you go outside and you stick your hand out there and you feel warmth on your arms, what are you feeling? Do you think you're feeling heat from the sun, the solar flares, the nuclear reactions? What do you think you're feeling? You're feeling photons. So there's a bunch the ones of the colors that you match get reflected off of you, but the ones that don't stick to you and they generate heat. That's how you get your warmth. So now that we got that out of the way, from now on I want you to think in photons. So we're not actually taking a picture or an image of a person or say a car, for example. We're collecting the photons reflecting off that person or that object to create an image. So I just really want to hit home with that because cameras operate according to this principle. So here I'm showing an example of the sun and it's collecting photons fast. Let's go to the next one. Oh, let's bounce back again. So if there's weaker light, there's less photons, less photon output, the longer it takes to collect photons, which means you have to open your shutter speed for a longer period of time. I wonder if I could, is this making sense so far to everybody? It's pretty basic. So, in order to collect your photons, you care about 3 things: your f-stop, your ISO, and your shutter speed. So, all these cameras basically have these capabilities. Some don't, but sorry, let me get back to here. So your point and shoots do, some do, like not all. I just learned that there's a couple brands that actually don't allow you to set your ISO and shutter speeds. But smartphones, so what I wanted to show you today was just something, because I said I was going to try this out, is I've actually got my smartphone here that I brought up here. I bought this zoom lens, and I downloaded an app called Camera 360 HD, and there's another one, something light. But you just do a search on DSLR cameras for my smartphone, and it allows you to set the ISO, the shutter speed, things like that. And those are the same things you need in a DSLR camera. So I brought that up here to actually see if I could capture the Milky Way, which I'm going to explain how to do in a moment. Then you got your DSLR cameras, which is right here. And then your deep space camera, and sitting in my car, I mean, I thought I was just going to stick in here, then I bought this, then all of a sudden I'm graduating over here. So be forewarned that if you get started in this field and you start capturing good pictures, you're going to start moving up that chain. So this is just a picture that cameras, so this is actually really important. So cameras have cutoff filters, so that you can take your images in visible light. Because if you didn't, you'd be capturing some of the IR and some of the UV, and then your pictures would come out like red or purple. So they have these cutoff filters. But if you want to use a DSLR for astrophotography to get things like nebula, you're going to need to have those filters removed so that you can capture this light and start to capture that light. And there's places that do it. There's a company called UTech. I think you could probably also ask Canon to sell you a camera that removes those filters. Next thing. Just thinking right here. Hold on one second. I'm going to see just what the next thing is. So, yeah, let's start with this, and I'm going to do a little experiment. Okay, so if you've got kids, I'm not sure if you've done this, but if you have kids, they probably have for you, is they've looked in back of your camera, if they flip that mirror, or if you don't have a mirror, you look back there, and there's something that looks like a DVD or a CD. But you look at that, and what that is actually your CMOS or your CCD chip. But in this case, I'm showing you a CMOS chip. And the reason it has all these colors, it has something called the Bayer matrix, which is how you get your red, greens, and blues. So I'm showing you the internal workings of the camera now and how they actually capture light. So when you open your shutter, you start to capture capture photons. I'm not going to go into details on how the Bayer matrix works. It's probably going to take too much. Well, a Bayer matrix, just on a CCD, each photosite is to collect a photon, which, using the photoelectric effect, turns it into a recorded electron. But when it comes to a color camera, CMOS, it uses one in the middle and then the ones around it to determine the RGB for that center pixel. So that's how you get colors, but you lose some definition. But that's probably enough to go into right now. So if you start with an ISO of 100 and you collect 3 photons, your camera records 3 photon strikes. If you change your ISO, so what's ISO now? So here we go. If you set it to 200, what happens is it takes the 3, divides the number by 100, so that's the number's 2. 2 times 3 is 6. So what happens is, as you increase your ISO, you notice that the picture you're taking gets brighter and brighter and brighter. That's because it's taking the photons that you collected, it amplifies them to a number that's greater than what you took. Is that clear? Or is there any questions on that? So that's how the ISO is actually working, is it records the photon strikes and it just multiplies the number that it recorded to make a brighter picture. And then what happens is these box, if you make it too high, have you ever set your ISO too high or left the shutter open for too long? It gets too bright. So what happens is your well capacity begins to fill up. And then when it overflows, you just get a white picture. So that's what that's all about. And I have a little experiment that I think that might make this clear, and I just need somebody who wants to help me with it. Anybody here? You want to help? Okay. So I think this will really, I came up with this because I thought it would really hit home for people. You can just stand back here so people can see. Okay. So this is my light source. This is my sun, and in here I have rays of sunshine. Yeah, it's actually popcorn, but they're bits of photons. So what I actually want to do here is, this is a well, this cup, and usually when you're taking pictures, you want to fill 1/3 of that well. If you go too high, it gets too bright. If it's any lower, it gets too dark, and I'll show you how that comes into play in a moment. But if you will, you're gonna use the shutter. Okay, and I want you to open it, and the photons are going to start to pour, but I want you to close it by the time it reaches that red line. Okay, so let's just say we're doing this so shut it, and then when I go, you can open it, go. Okay, that's fine. I'm gonna pick that up later. Okay, so that actually took about 2 seconds. Okay, so that would probably be a good photo for something as dark as this room, or maybe slightly darker. So if it was darker in this room and you were to take a picture, you would set your shutter speed to about 1 or 2 seconds, and you set the ISO to 100, and you would get a picture. Now, let's just say, I want to make this a little bit more. You know what? I'm going to make this a little bit more difficult. The reason I use it at this thing is I'm just going to fold this up later, so it's okay. So let's do one more, okay? So now, let's just say, let's just cover it. And now it is noon on Saturday, and it's clear and bright, and there's a lot of sun. So what's going to happen? Here we go. Go. Okay. So the photons came pouring in. And he got that in about 1 second. So let's have a round of applause. So the point being is that when the photons are flowing slower, that's when you have to leave your shutter open for longer. And then if it's bright, then you make your shutter speed like 250, 1000 or something like that. And then you play with that. So there goes our photons. They're all over. Okay. So the moon and the planets do not emit photons. They need reflected light from the sun. I think most of us already know that. There's a lot, when I used to give this brief to kids, they somehow think or thought that the planets reflect or that they create their own light. And obviously we as astronomers do not. And I do not mean to insult you. These are made for kids. But sun, stars, and galaxies and nebula, not all nebula emit their own light, but all the light does come from one source, right? They all seem to be coming from stars. I don't think there's not much out there. And if there's a nebula that's glowing, it's because there's a star that's nearby that's exciting the atoms of the nebula, which makes it glow. So thank God for that. So if you're going to get started, camera system using a lens. If you want to start doing nighttime photography or astrophotography, this is basically what you want to get started with. So this is an important slide right here. So you can use any DSLR, any point-and-shoot camera, or any smartphone with adjustable ISO and shutter speed, which we know now. A lens, it could be any lens. I'm recommending it as something between 55 to 300. If anything bigger than this, then you can start to get into the realm of like telescopes. So, and any mount, you could start taking your first pictures with any mount. It doesn't have to be a go-to mount. Camera system using a telescope. I'm just giving you something to start with. 6 inches or greater reflector, 3 inches or greater refractor. I'm recommending an APO. In case you didn't know, an achromatic telescope aligns 2 colors, then APO does all 3, red, green, and blue, so you get sharp pictures. But I recommend getting 3 inches. Do not go to Kmart. Parents come to me all the time and go, I'm going to get my son or my child a telescope for Christmas, and I'm going to go to KB Toys. It's got the plastic lenses, and it's like a 1 or 2 inch telescope. And then on the box, they actually show these big defined pictures of Saturn and Jupiter. I'm like, you are not going to get that with that telescope. So I'm telling people to get a real telescope, at least 6 inches for reflector and 3 inches greater than refractor. Mount, any mount. If you're going to do good astrophotography, you want a mount that's motorized with go-to tracking. Highly recommend an equatorial mount. You can also go with alt-azimuth and Dobsonians. The reason you want an equatorial is it accounts for the rotation of the Earth and the rotation across the sky. So when things move across the sky, they just don't move across the sky like this or straight. They move in an arc, and you actually need that thing to rotate with the image. So that's why you got to get an equatorial mount, which is what this is. And then your camera, if you want to get into the good stuff, then you're going to want a planetary camera or a webcam, a DSLR, or a dedicated deep space CCD camera. Are there any questions with this? This is kind of just to get you started. So right away, this is something it took me forever to learn, and through web page searches and books and a lot of reading, this is what your settings ought to be. So if you're going to go out there tonight and say, this guy at the star party told me I'm going to go out, that these are what my settings should be. You want to set your camera right away to manual or bulb. I will show you the difference in a second. Your ISO 800 to 1600, your f-stop to the lowest number, your white balance to auto or daylight. You can use either one. Some people start to get into to custom white balances, but to get started, you don't have to do that. Who knows what white balance is? What's that, Alan? Also, I'm just asking you.
It's a relative sensitivity ratio between red, green, and blue to compensate for the different colors of the illumination.
Okay.
Primarily between indoor and outdoor or overcast.
Okay. I'll run with that. What I'd like to say is, for the conditions that I'm taking now, this is what white should be, or what white is in this environment. Would you say that?
So that white comes out looking as white on
As-
the screen.
Yeah.
Right, because human perspective.
Yeah.
Right.
So I've done this in scuba diving, for example. So you go down to so many feet with a whiteboard, and you take a picture to say this is what white is, so that the rest of your stuff looks the way it's supposed to. Your autofocus should be set to off. You cannot autofocus on nebula. I mean, I don't know if there's any sophisticated cameras out there, but you're going to need to manual focus on most things that are in outer space. You want to set your format to RAW, LRGB, because you don't want to use JPEG. What happens is, when you image something, deep space, you want to capture every piece of data about that object, and you don't want it to be cut off. So a lot of times when you take a picture, you may not see some of the finer data that's there until you begin to post-process. And when you post-process and you do things like increase saturation, brightness, and contrast, the nebulosity starts to come out, the colors really start to come out. But if you shoot in JPEG only, you lose a lot of that data, because in order to compress it, it turns into a lost data, you will lose some data. So try to shoot in RAW at all times. You want to turn your flash off. Obviously, I'm teaching you how to not use flash. Your autofocus, again, it's in there twice, I apologize. Your mirror flip is on. Who knows what mirror flip is? Always in the back.
So when your mirror of your camera flips up, it will cause the camera to vibrate, where if you set your setting so that the mirror is flipped up before it starts exposing, it will minimize that vibration.
So I just set something up so that people could see this. This is what so do you remember I said that you should set your camera to manual or bulb? If you set it to manual, that means you're not using one of these. You would still be using the shutter on your camera, okay? But if you're using one of these, you want to use bulb. So what's the benefit? So as he just described, it flips the mirror first, which is what I'm going to do. You probably just heard the mirror flip. It's done vibrating. Now I take my picture and it's done. So when you do long exposure astrophotography, you want to do everything you can to minimize vibration. And it all begins to add up. You know, you want a stable mount. You don't want the mirror to cause vibration. You want, you don't want to cause vibration is what it boils down to. Long exposure noise reduction, very important. Who knows what this is? I'm going to give somebody else a chance to shine. Back there, Arlen?
So it takes a picture, the camera itself, and this is the long exposure noise reduction on it, takes a picture with the internal shutter of the camera shut, and that just captures the noise of the sensor. That picture is taken for the same exact length of time as your light picture is taken. That light picture is taken first, then it closes the shutter, takes an equal exposure, and then that noise is subtracted from the first picture, and it reduces the noise dramatically in the photo.
Yep. So that sounds to me a lot like a dark frame.
Yes.
Okay, so that's what it is. It's a dark frame subtraction built into the camera. But one of the problems that you're going to... so that's something you always want to do when you're doing nighttime astrophotometry. If you're just doing a picture where you're capturing a building or a cityscape or one shot of the moon, that's fine, okay? But if you're out there where each exposure is 5 minutes on a cold winter's night where you saw the guy who was freezing out there, if you turn this function on and you take a 5-minute picture of something, the shutter closes and you got to sit there for another 5 minutes while it does the dark frame subtraction. So your 5-minute picture just became 10 minutes for one picture, okay? So this is good for if you're doing astrophotography for 3 minutes or less, because it turns your 3-minute shots into 6-minute shots. Okay, that's fine. I can live with that. But I can't live, if I take a 10-minute shot, I'm not going to wait 20 minutes for each one. So what astrophotographers tend to do is they do all their images first. They keep this off. They take all their pictures first. Then at the end of the night, as they're packing their stuff and they're putting things away, they put the cap back onto their camera and they take an exposure for the same amount of time and they capture all the darks separately, and then they have software at home to help to do the subtraction through a computer. But if you want to do 1 or 2 shots tonight, you might as well just turn it on. That's what that is. Questions? I thought somebody's hands was raised. Not anymore?
One of the other things I'll do is a lot of times I'll use the timer. If I'm only using the button on the top of the camera, I'll put a 2-second timer, a 10-second timer to remove some of the shake.
Yeah, so if you do not have your remote switch, the way that you can do the same thing is you do the mirror flip, then you take your second picture, which gives you 2 seconds to step away from the camera and let it take its picture. So you can use the timer. It's a good idea. More questions? Good. All right, this is great stuff. So these are settings you need to do something for a cityscape. I took this from somebody else online, havecamera.willtravel.com. I have taken pictures like this. They're not as, I'm not that much of an artist. I am a photographer, but I'm not a super artist. So, and I usually have people walking in front and things like that. But I took a look at my picture that was very close to this, almost identical, quite frankly. And I used a DSLR camera, but it could be any digital camera. You're going to want to mount to a tripod, set the ISO to 1600, and the exposure time in this case was just 1 second. And the reason it was 1 second is because there is a lot of light in Washington, D.C. So do you remember things that, so if you have ambient light that's bouncing off the target, you're just going to get you're going to get those photons, like going to pour into that cup real fast. So to get a good picture of the Capitol building, 1 second at 1600 ISO, point and you focus on the target. Now you may be able, because there may be enough illumination of the target that you can auto focus, but I still recommend turning it off and just using your hand to focus. Use your timer or the intervalometer so you don't touch it. Don't move the camera. And if it's too dim or too bright, you can make corrections by the ISO and again the exposure time. So this leads me into the next shot. Let's just say I shot this at 800 ISO and you go, you know what, this is kind of dark. Why don't I try bumping it up to 1600 ISO, okay? And at 1 second, it's perfect. Well, let's be a smart guy and go to 3200 ISO and amplify all those photons that I've captured from 1 second, and now it's too bright, so you want to bring it back down. But you may be asking yourself, what is the optimal setting, the most optimal setting? And I'm going to show you how your camera can tell you that. But over here, I'm showing a teeter-totter because this is a question for the crowd. If I have an ISO at 800 in 1 second, but I wanted to keep this at 800, what could I have done to make this picture? Is there a way that I could still do it? 2 seconds or 3 seconds, for example, right? So you just, those are the two things that you need to play with, and that's about it, okay? Now, what if I'm taking the same picture, but there's something moving like traffic? Go ahead.
On the subject of the ISO, I'm trying to understand. On old-fashioned film, a different ISO film was actually a different chemical that was more sensitive or less sensitive to the light. On a camera, the sensor sensitivity is what it is, right? So what you're adjusting the ISO is a multiplier, sort of like a gain setting on the capture, right?
So when a photon comes in and it strikes a well or a photosite, it gets recorded through something called the Photoelectric Effect. So that it's usually a 1-for-1 ratio for a strike, but cameras aren't perfect, so they really record like maybe between 60 to 80% of the photon strikes. And then they turn those into electrons that are stored and then sent to the converter. Is that answering your question?
And then when you change the ISO, then what are you really changing?
In a digital camera or film?
In a digital camera.
So what you're changing is you're setting the, you're telling your camera, for example, if I go from 400 to 200, if I captured 3 photons and I had it set to 400, it was taking the 4, multiplying it times 3 to give you 12. That's all.
You decided that you go 12 instead. So
but then it's going to get brighter and brighter as it goes up the chain. As the well increases, it gets brighter and brighter.
So what I thought I heard you say initially was that your camera is always going to take pictures as if it's at ISO 100. If you're at ISO 200, it's going to multiply those photons by 2. Right. You go to 400, it
That's right.
multiplies it by 4.
Yes.
1600 multiplies it by 16.
Yeah. So and they're in those increments: 4, 8, 16, 32. Yeah.
okay, so how is that different from, say, doing something post-processing to say, okay, you think that you captured this, but you actually captured this much? Like increasing the brightness of the picture post-processing. Is that different? Do you get different effects from what you would get by changing the ISO?
So there's a small nuance.
No.
The output of the sensor is analog. Okay. There's a gain block there before the digitizer, and that's what's being adjusted by the ISO.
Okay.
And then from that point on, it's just numbers. And some of the camera settings, some of the ISO settings are just playing with those numbers mathematically, but some are actually changing the gain block that's before the digitizer.
Okay. That makes sense.
Some nuances there.
The well for each
Photosite.
photosite
Yeah.
is only so large as well. So
Mhm.
you can actually go and fill one up, and then you start losing information as you don't know how much more there actually was.
Yeah, and then you start to get into the dynamic range, and which this doesn't get into too much. 'Cause I'm still trying to keep it simple.
And so if you dealt with things like that post-processing, rather than trying to deal with it right then, you wouldn't have that problem with if you're having wells filled and not really knowing how much there was.
But one of the things you do, so here, this is actually probably really important for those that want really good shots, like you saw of the Capitol building. The lower the ISO setting, you're capturing more true data, okay? And as you're filling up that well, you're actually capturing true data coming off the target, okay? But if you do something real quick, so a prime example is this, and this is really going to make it clear. If you take a picture of the Orion Nebula, and if you really take a low ISO, long-term exposure, you will see pinks, oranges, a little bit of purples and blues from the different wavelengths that are coming off of it, okay? And which I'll show you later, but let's just say that you set that ISO to 3,200 or 6,400 and you just do a snapshot. The initial light it captures is probably going to be, a majority of it is going to be the hydrogen alpha, because that's what just is what that's made of. It's just, there's so much of the hydrogen alpha. But this is what's going to happen, is it's going to get that pink, or it's going to compute the pink, but then it's going to take all that information and it's going to multiply it by 3,200. So what you're going to get is you're going to get this big pink nebula that if I put it side by side with something that I took like for 10 minutes with 100, you're going to see little tiny wisps and swirls of different colors and more detail than you would with something that you're just amplifying. So you're getting less data, but you're multiplying that less data, and then it's just not as good.
You're amplifying the bright stuff, not taking the time to get the dim stuff.
Yeah, you just captured real quickly what you got, that quick snapshot. So if you really want to take good pictures, I know that everybody in here is going to say, I'm going to go out to my camera or to my telescope or my camera, and I'm going to turn because I want a picture just to show my friends, okay? And that's going to happen. And you're going to show, hey, look at my great picture. And then you're going to come across and go, look at this. Okay, and you're like, well, how did you do that? They go, I took flats and biases and dark frames, and I took 32 of those, and you're like, oh, I'm gonna have to get that. And then all of a sudden, I'll show you how this becomes addictive. So I think we're good with this. We're good with this. I think we made some headway. So you took a still shot, but because this was moving, you've got the motion in it, right? So I'm going to start to get into light painting. This is something I think I found on the internet. It's just a perfect example where somehow somebody got the Milky Way, and they also got this barn that's lit up. Who thinks they know how this picture was taken? Go on.
What he did is he took a long exposure, but then he did one quick flash of the barn so you could see the barn.
So you're right. So in this case, I just said he just put a flashlight on it. Yeah, right. Or he just shined, or he just painted it real quick and then stopped. So that's all you need to do. I don't recommend taking a flashlight here because you'll make the astronomers angry. But when you get home, go downstairs and do something, and you'll be just amazed at what the results are. Then there's laser paint. There's painting with lasers. I wanted you to prove to you that I could do this and I knew something about it. But again, I'm not an artist, so the best I can do is I could write my name. So I used the Canon 5D Mark II. It wasn't modified with anything. I set an ISO to 800. Set the exposure time for 15 seconds in my basement at nighttime, and I made sure I closed all the blinds and things like that, so it was dark. And then I said go, and first I focused onto my wall. There was like a light socket, and I focused on that, and then I turned off the autofocus and everything. Turned off the lights, and then I had 15 seconds to just do this JOHN. And so I tried it with a couple of lasers. Obviously, these green lasers are a lot more powerful, but if you want to amaze your kids, you could start to show them this. But this leads you into the next step. So like I said, I'm not an artist. I just use this to draw my names. But then there are people that get into this whole world where they get, this is actually incredible since I don't know how they, so I did do some research into this. You could use a laser. There's also these wands with these glow tips. They're called brushes. And what they do is, a lot of times the artist will just put on something black with a black ski mask and just face the camera and draw. And he doesn't get recorded, but the light does. Or what they sometimes do is on the wall, they will trace something, and then by just the laser light alone, they can kind of see the outline, and they just whip through it. But that's kind of cool stuff that you could do. I just got these because I thought these were really cool. I'd like to know how this guy did it, through some post-processing maybe. Obviously, this is probably just up against the wall. It's a very good job. So if you think this is going to take like 30 seconds to draw or like a minute, then you set your exposure time to a minute. And then you just start moving the pointer and it draws it. Questions? It's pretty easy, right? Because we're collecting photons, that's all we care about, remember? All right. Now let's take this into astrophotography, okay? So what have we learned? We care about capturing photons, right? If you're going to start capturing outer space, you want it to be, well, the ideal conditions are clear, cool, dark, dry, and a stable atmosphere. Now, last night, I guess this came. This, I don't know, was questionable. We definitely got this. This was not the case, and that was not the case. But you could still function. What you can't function is, well, I remember when I made this slide, I made it from like, worst to most worst, I guess. So can you do it in overcast? I mean, you don't want overcast. You can shoot in between things we called sucker holes, right? Where there's and by the time you bring your telescope to it, it's already closed in, and there's one that pops up there. I recommend that if it's, now that I'm thinking of this, this is, worst to most worst. So you can still, this is most worst to worst. So you definitely cannot, if it's totally overcast like it is right now, you cannot do it. If there's wind, you are not going to be able to do long exposure astrophotography unless you got some special software that accounts for vibrations and stuff. But I don't know why you would go through that aggravation. Unless you're shooting the moon, you don't want the moon. I mean, the moon's your enemy. If you're trying to get a picture of a deep space object, the light of the sun reflecting off the moon is going to white out your picture, and it's going to ruin your shot. You might be able to get away with it if the moon's coming in this way, but you're taking a picture of something from that direction. But again, the reason they have these almost having star parties is when there's a new moon, which means there's no moon, is so that everybody here can take pictures and have good viewing. Sky glow. You don't want to be near cities. That's again why we come out to the almost having star party here at Spruce Knob. There's ways to get around sky glow through like special filters. Is Kevin Quinn here? He's not. Which incidentally, I'm sort of the introductory on Astra Imaging, but Kevin Quinn is going to show you how to post-process. So I recommend you see his brief. I think it's at 1:30, or something like that, right, guys? And then Dr. Stacy Williams here. She's does some imaging for the Department of Defense, and some of the technologies and the pictures they take are just incredible. So sky glow, heat. You definitely do not want heat waves in front of your lens. You begin to get distortions, just like you see heat coming off. I've taken pictures where I actually made a mistake, and I took a hand warmer and I stuck it into my dew shield here, and boy, did I make a mistake. I will never do that again. So I broke down and I bought a dew heater, but I still use the hand warmers to tuck under the guide scope and by the focuser. And sometimes when it really gets cold, so I've been out there when it's 17 degrees below zero, not below zero, but like 17 degrees. A lot of my equipment will start to malfunction, so I'll open this up and stick a heater into the machinery itself, and then it seems to work again. Humidity, you can get away. You definitely don't want humidity. We know dew. Who knows the problem with dew? Last night, anybody? Okay, most of the hands were raised there. Okay, so are there any questions on this?
Just one thing on the moon. If you're shooting through some filters like hydrogen alpha filters or oxygen filters or something like that, you can get away with a fairly infinite light and still get a reasonable image.
So, you're going to make me think here. If you're shooting in narrow band, So I might need some help from my fellow astrophotographers. So it seems to me that even the sun is emitting things in hydrogen alpha. So you would get hydrogen alpha reflecting off that moon. Yeah.
But the work I've done with HA, I can get away with a quarter moon, a half moon,
Yeah.
and really see very little difference. It's stripping out all the hydrogen alpha light that's not going to space-time.
Yeah. So yes, you can, and that's why it's in the top 3 here and not at the very front, because you could still get away with it, right? But you'd rather not have it unless you're shooting the moon.
It's also a good time to practice with your other gear. You know, why wait for that one pristine weekend where it's a moonless night, and then, oh, I don't know how to run my equipment.
Yeah, which I'm experiencing right now. But okay. Yeah, so I brought a bunch of new stuff, and I said, you know, I got 4 or 5 days to try it out, but with the rain and the dew and all that, it's been very difficult. So I think this all makes sense, but pretty much I recommend with these top 2, if you step out of your house to do imaging and there's wind and there's overcast, just go back in your house. Do you think you're going to go up there, set up, it's all going to clear up? I doubt it. So, I mean, you're stuck here, but if you're just going to randomly go out in the field, don't go out. When it comes to doing astro imaging, here's a recommendation. Well, it's not a recommendation, it's a fact. So, in case you don't know it, if you shoot something that's straight above you, you're cutting through one Earth atmosphere. Okay, it's pretty simple. It's straight up. But if you are having to cut at something at a very low angle, you're cutting through a lot more atmosphere. And the atmosphere is made of humidity, particulates, pollution, and all this other kind of nasty stuff that you have to cut through. And then what also begins to happen over all this time is you get atmospheric lensing that causes diffraction of the light. And I don't know if anyone has ever looked at a planet or anything that's low on the horizon, but it gets broken into 3 different colors, right? Red, green, and blue because of this atmospheric lensing. And it begins to bend the light. So, recommendation is image anything that's 30 degrees above the horizon from that end to that end. That still gives you 120 degrees field of view. So, as you can see here, let me just go back. So this is a chart. You know, your best is at 90, 75, 60, 45, but you don't want to do 30 and under because you start to have to cut through 2 air masses, 3.9, 3.8, whatever. So that's pretty clear, right? So if you go like this, if it's below your arms, then don't take it. If it's up there, that's good. All right. The almighty cup. I'm trying to see if this makes sense, but hope I can make it stick. So if you take so let's just say you don't have a cup in the field to measure how many photons you're collecting, but you got your camera. What you do is so do you remember when, if you're taking a picture of a nebula, did I put a picture up here for you? Just hold on real quick. I just want to look at something. Okay, so if you're taking a picture of a deep space object, I always remember start about an ISO of 800, so I'm going to just tell you this. It's not in the slide, but it's an important note. Started at about ISO 800 for 5 minutes of a deep space object. It's either going to come in too bright or not bright enough, okay? But at least that's a start. You are going to get something. Depending on, and it doesn't matter what kind of telescope you have, from f5 to f7 to f10. You're going to get something, okay? But what you want to do is, do you remember the cup where you're trying to get one third of the way? You want to do the same thing with your histogram. So if you have a Nikon, Olympus, I guess, probably, and a Canon, after it takes the picture, you can click info, and it shows this tiny histogram. You want to make sure that your data is collected within this 1/3 area. It could be slightly over here or slightly over here, but if you start to go into these bands, you're going to realize that your picture's whited out, okay? So all I'm showing you here is if you have a Canon, you take a picture, and you go, was that okay? Well, look at my red, greens, and blues that make up this histogram, and they're all in about that 1/3 spot. So I'm going to be happy with this shot. So question for the crowd, if my ISO, question for the crowd, if my ISO is 1600 for 5 minutes, 1600 for 5 minutes, and my histogram is over here, I've overexposed, what do I need to do? Just lower the ISO, and Exactly, and that'll start to bring it back. But if you can, I'm making a recommendation that you always try to keep your ISO at its lowest form and increase your exposure time. It's just, so here's an example that if you take a picture of something at 12,800, which is multiplying your photons to create a gain of 100 to multiply it by 128, for just a couple seconds, you're going to get all this read noise, okay? But if you have a lower ISO for a longer period of time, you will get smoother data. So regardless of what I have here and here, I could still use dark frame subtraction to get rid of this noise, but you'll do a much better job here. And if you look at this star, you can see pinks and purples and stuff, where this is just one big pink blob. And that's what I was talking about. You'd rather not have the higher ISO.
If you're dealing with a mount that's not moving with the space around you, though, shortening your exposure time can give you a more crisp picture of the sky because it's not moving from underneath.
With the sky, yeah. But I'll get into how you can do that. All right. So here's some of the pros. If you have a higher ISO setting, your pro is a shorter exposure, which you just pointed out. You have battery conversation because it's not rocking and rolling for a few minutes at a time. It's just 1 second of battery use. Less color depth, though, that's dead common. I was telling you about that color depth. But more color noise, which is what all this junk is. If you lower your ISO setting, you have more color depth. Remember I said because you're gaining more real data as opposed to amplifying what first got there. Less color noise. The con is you have to sit out there. It's a longer exposure. Your battery life is reduced, but then there is some noise from heat because it's on longer. Okay, but you remove that through dark frame subtraction. Is this making sense? The cup and everything and the well. This kind of shows you how much your wells are being filled up as it moves from left to right. So this is black, and that's bright white on this side. Very important. So when you take a picture of a deep space object, in any book or any photographer will tell you, you have to set your camera lens to infinity, and it's that little thing here that looks like a figure 8, okay? And then also for your telescope, I'm going to show you how you do that. So what's infinity focus? That means that by the time light is reaching you, it's already parallel. So you need to get your lens into position to expect totally parallel rays. Now it's not perfect, but it's close enough to being perfect. Parallel rays. So if you're close to an object, you have all these lights, these photons that are coming in from different angles, but they're not parallel, which is why you have to focus. You have to focus on just a set, so you have something clear. But once something gets so far away, all these different angles are shooting in different directions, but only the ones that are parallel actually make it to your eye. So when you look at a star, they're already parallel. I mean, they have to be to reach your eyes, or else you just wouldn't see them, right? Right? Make sense? All right, I just want to so you finally reach a point where if this star was 1 light year away, and I wanted to take a picture of something that's 10 light years away, does it matter? No, because by the time you're seeing it, its rays are parallel, which I think I made clear over here. Are there any questions about this? I think that's pretty straightforward. And then you're going to ask yourself, how do I do this with my telescope? Okay, I don't have here some kind of some little figure 8 symbol. So what you do is you have something called the Baton Off Mass. You spend your $5, you get yourself a Baton Off mask, and that actually hangs on the front here. And what it does is this. So there you go. So you know what, the picture is already up. So as I adjust the focuser here, and I go back and forth, as I go back, this center line will start to swing this way. When I come back forward, it swings this way. I keep working this until it becomes perfectly centered. And you get a perfect, then you're focused at infinity, and then you know. So then, at which point you just say, okay, I'm focused at infinity, you lock it down, and you have to have some kind of reminder, a string on your finger. What I tend to do is hang your Baton Off mass by 1 screw. And why would I do that? It'll fall off. And what happens if it doesn't fall off and you forget about it? So, You do. And so I have been out there where I was imaging for hours and I thought I was getting the best pictures. And then the clouds were starting to come. I go, but I've got my data. And then I looked at it and all my stars were X's and my objects were askew. And I'm like, oh, I left on the Baton Off Mass. So when enough of the astrophotographers have had drinks in them, they'll tell you that they've done the same. So don't think I'm the only crony. So once you do that, you focus at infinity. I just want to see something here. I think it's probably an important, so let me just do this now. It'll just make it really clear. So this is for some of the new people who are new to this. So they'll ask, how do you hook up this DSLR to a telescope? And it's actually pretty simple. I'm going to just pop this off. And it's probably stuck in here. There you go. Just pop it off of here. And just like a camera lens, you just pop this off. Should be just fine. And this is called a T-ring with a T-adapter. And you buy the T-ring for a Canon, a Nikon, an Olympus, Pentax. They're just different brands. And you get the T-ring, and then you buy a T-adapter for it. I don't know what that was. So. And then you get a T-adapter for it. And the T-adapter will screw into the T-ring. And then you get something like this. So this is the T-ring and the T-adapter. Snap that in there. Goes right into here. And of course, I just lost focus, so I have to put on my Baton Off mask. And then, so this is actually pretty helpful. If you actually turn on the live view mode, you'll get that star that you see back there. Put this on the front. I focus until it's nice and focused. Then I lock this down so it can't move like it just did. And remove the Baton Off mask, and you're ready to so then you swing something that you want to image, and it's already set to go. And then you just use your intervalometer, which I'm going to talk about next.
Can you set the focus independently before setting the camera on, or is that, or do you need to take pictures with the camera to set the focus? Am I making sense?
Oh, well, I'm sure there's a way that you could like hold a piece of paper up to the back of the outlet of the focuser, and if you see an X on that piece of paper, but then you have to account for the depth that you're going into the camera.
Right. Well, that's what I'm getting at. So when you put the mask on and you want to focus on infinity, don't you have to do with the camera and take it
On,
with
yeah.
the camera
Yeah.
versus like looking through the eyepiece?
How do you see the star?
Because you want it focused on the sensor of the camera, not
Right,
on
right,
wherever
right,
your eye
right.
would be.
Yeah.
Yeah.
Right. That's why I want to make sure I understood that.
Yeah, so you want your camera on there. And of course, if you have a CCD camera, then you got to use software and a computer to kind of do the same thing.
Have you seen the difference with the Baton Off mask and dew shield as far as distance
No.
from the objective?
Oh, you know what I do? No. So I actually put that inside my dew shield, up against and then I pluck it out with my finger when I'm done.
But it won't matter if the light rays are parallel. You can put it 20 feet out if you did it in the right place. Setting the gain of the camera at that point, you don't want to spend 5 minutes getting that focusing image, so you just bump up the gain. Once again, you bump up the gain to get your target frame rotated right. Then you drop the gain down to what you're actually shooting.
Okay.
So if it's one thing I just wanted to get across to you is if you wanted to image anything that's deep space, a galaxy, a nebula, anything, you just find a star first, you focus on it, and since you know that if it's focused on that, it will be focused on anything else in the universe, and you just swing it over. Because when I first got started, I'm like, if that nebula is 1 light year away, but that one's 36 million light years away, how do I focus? And then had to read up on infinity, and it doesn't matter after that.
So can I noticed you need a pretty bright star though with the mask on. What kind of magnitude star do you
You know, I usually choose one of the big three in the summer, from the triangle. I'll use Celestine. I was using a Vega, Arcturus, and then I'll use Sirius. But it doesn't matter, just as long as some bright star is. And then you swing to your target, and you start taking pictures. Yeah, let's just get... so we talked about the remote switch. So because you don't want to stand there all night and keep doing this, right, for like 2 hours, what you do is you get yourself an intervalometer where you can set, the length of the exposure, the number you want. So I'll set this, take 30 pictures, each at 5 minutes, and take a break for 3 seconds in between. And then once I set this, I go, and that sucker just starts to rock and roll. And then I can go and have a glass of wine and talk to my friends and socialize. Although you do have to keep coming back to just check on it, but it's no big deal. This is if you don't have the fancy computer screen and you just use like your phone to say, oh, it's been 2 minutes, and you just have to hit it again. But why go through that aggravation? Pay the money and get that. Okay, how do we shoot the Milky Way? So this is, if you're planning to do this tonight, you may want to take a shot of the screen because it's pretty clear. It's any mount, it's any camera. The best lens to choose from is between f1.5 to f3, anywhere between 50 and 30 millimeters. The reason you want these lower numbers is so that you get a bigger field of view. You don't want to be really tight on it. You want the Milky Way, right? So you want to get the lowest number possible. Set the ISO somewhere between 1600 and 3200. There's something called and you can play with this. This is just me to get you started, okay? But if you're like, oh, that's too exposed, I'll drop to 800 because I learned about that. Something called the 500 rule. You take 500 and you divide it by the focal length of the lens. So in case, if I used a 20 millimeter lens, it means I could expose for 25 seconds. So if you're going to put on your lens and it says it's a 25 or a 20, so you pop it in there, you point it at the Milky Way, and then you say, well, okay, so 20 goes into 500, and I get 25 seconds that I can expose. So you set your exposure time to 25 seconds, or you use a remote switch, or time it to prevent vibration. Point it at the Milky Way. We already know about focusing in infinity. We know how to do that, right? For infinity, take your picture for the computer exposure time, in this case 25 seconds, and then you will get something that looks like this. You'll actually be shocked. You're like, oh my God, I did it. I didn't think I'd ever be able to do it, but I did it. And then you can post-process with an application. So perhaps you want to make it a little bit brighter or something like that, or add some color, who knows. But that's how you get. And so I actually found this little bundle. I do not work for Orion. I'm not trying to, in fact, you should probably go to Explorer Scientific. Is the guy here? So they actually make a very good bundle for $179. You actually get a tripod with a motor that can take a small telescope or a camera, and it works very well. So it's not bad for that price. How do I do those things called star trails? This was taken at the Almost Heaven Star Party 2 years ago. I still don't know who the author is. I keep asking, but somebody here took this, but I know how he took the picture. He used any mount, any camera, set the ISO between 4 to 800, point at Polaris, which is the North Star. Optional intervalometer, and the only reason it's optional is because, like I said, you can use the timer just to get it started, right? But and then you just have to hit it again. But you take 5-minute exposures for 2+ hours. So what does that mean is, that's where the intervalometer comes in handy. So 5 minutes goes into 24. So you take that many exposures. And but you don't want more than 5 seconds in between each one, because what happens is you're going to get these star trails and they stop, and then your next picture is going to have star trails and they stop and they go and stop, go and stop. And then there's software called Photoshop Star Trails Action, and there's another program called Star Trails, and that just allows you to bring in all those pictures you took throughout the night, and it adds them together so you get the big circle. Okay. I don't know many people who have a complete circle, because that means 24 hours of rotation. And there's a problem with daylight. Another question that people ask is, what's the best time to do it? Probably between a couple hours after sunset till whatever, 4 o'clock in the morning. Just let the thing run all night and try to get as many as you can. But it's actually pretty simple and something that you can do while you're here with any camera. Any questions? Oh, okay. Okay. Oh, yeah, probably size. I don't know if that could be traffic in the.
I think that was probably my daughter running around with her friends with red lights.
I know exactly what that is. If you look at this person here, he's kind of bent over. I bet he was just walking.
But aren't they?
Here?
They seem higher, though, but they're not just because of the angle that I'm looking at.
It could be anything. I mean, in this case, like I said, I didn't take this picture, but I'm highly confident. That's probably traffic, an airplane maybe. It's in the distance. Yeah, that's what I'm thinking. Okay, so don't move cameras. That's something you could do tonight. Very good. I already covered this earlier, it kind of made sense. So what I showed you is something called prime focus, but if you want to use afocal projection, what that means is you stick something like a Barlow, an eyepiece, or what's the one by Teleview, the PowerMate in between. And I started with this, but what begins to happen is as you attach all these elements in between, this begins to hang like way out here, and your camera begins to warp and bend down. And I'm like, why do I even want to do that? I'll just hook it up and do prime focus. So, but you can try this if you want to do it. So again, the T-ring and the T adapter. Beginner astro imaging, the moon. Okay, so let's talk about the moon. Any camera, doesn't matter, lens between 1 and 300. You can get a smaller lens, but I think when people have their smartphone and they see the moon and they see a big, beautiful moon, and then they take a picture and they post it on Facebook. I think they see something that looks like this when it's a little tiny dime, okay? So you probably want a lens that's between 1 to 300 for a good shot of the moon. Any mount, tripod, set ISO low between 1 to 200. And why do we want it that low? Yeah, it's bright, right? So recommended shutter speed to start at, again, it's just recommended about 1/25th. Point it, focus manually, optional interlinear, take the shot and adjust the ISO and exposure time as necessary. So I just want to show you this. Here's a shutter speed that I took, that's 1/200. That's obviously the shutter speed's too high. And how do I know that? Look how dark it is. Okay, so let's lower the shutter speed so it stays open for a little bit longer. Drop it down to 160. But not only is it too bright, but now what am I catching? I'm catching the motion blur as the Earth's rotating. There's that sweet spot that you got to find with the moon, but this is a good place to start. Any questions?
You left out what I feel is the most important thing there. The full moon casts no shadows on the moon. A picture of the full moon, even the best one,
Yeah.
is kind of blah. You get a quarter moon where you get the sun, the daylight, where all the shadows are casting into the craters, and you get a whole lot better picture,
Yeah.
just because it's much more interesting.
Yeah, it is. It is. Well, then you can start to image the moon in LRGB and then you can start to bring in different colors. The moon's actually very colorful too. So there's a lot you can do with the moon. It's not boring.
John, is that ISO and shutter speed? You're probably talking about f/16. You didn't say when
Oh, okay. Yeah, I guess I didn't hear. Did I? All right. Yeah, I just used my basic camera and took a shot. All right, this takes you to the next level. For people starting out, this will get you started. You can use any mount. This is just to get your first shot of a nebula. You can use any mount. In this case, it doesn't have to be guided. Okay, you eventually will want one, but it doesn't have to be guided. You can use any camera, provided you can still do those three settings: the ISO, the shutter speed, and the focal or the aperture. In this case, the Orion Nebula. Now, I understand Orion is not up right now. Okay, I got that. But talk to any of these astronomers and say, show me a bright nebula, and they got the lasers, and they will point at something for you. And just pay attention to where it is. One of the reasons I pointed out this nebula, out the Orion Nebula, is because you can almost kind of see it, okay, with your naked eye or with a pair of binoculars. So point your camera on it. Remember, you have to focus on infinity. It's probably in there. And if you do that and you look, you're going to see it in the diopter of your camera. You will see the nebula. I'm like, man, it's pretty cool. So take a 15-second exposure. Do not move your camera. Set the ISO to kind of high, right? Between 1600, and you may want to go to 3200, which I've done. But like I said, we just wanted to get something to impress our friends. You will capture something. So this is my first shot. Here you go. Look at that. And I was like, I actually took a picture of a nebula. And, it is horrible. It is full of, there's vignetting around the ends, which means there's like a big circle with brighter light in the middle and dark in the edges. There's coma. Okay, it's horrible. It's all these stretched stars. But, boy, did I show all my friends. It was on Facebook. I drove my friends nuts. This is my colleague there, Tim. I drove him nuts. Look at these pictures I took. And then I came across, people like Bob Traub and and Kevin Quinn. And then, after 7 years of trying to do the same thing, this is what it looks like now. So in this case, it took an Explorer Scientific 127 ED. My mount is this equatorial mount, Canon 5D Mark II. I actually got this with a 5D Mark II. It's actually pretty impressive, which I didn't expect I was get. And I also used, I think I actually 58, okay, 58 total frames, 5-minute subs, okay, took 36. I also took 22 with the Lumicon Deep Sky filter. The Lumicon Deep Sky filter blocks, it's a very good filter. It's a little pricey, but it's actually worth it. It blocks out all the useless light except for hydrogen alpha, beta, O3, and I think some sulfur too. It lets in the 4 wavelengths that we care the most about. And I screwed that to the top front of my camera. And I got the reds and the blues and things like that. So I took 18 darks, 18 flats, 18 bias frames, which I'll speak about in a second. I use stacking software called Deep Sky Stacker. So if you're going to get started in this, just say, this guy at the Almost Heaven Star Party, John, said, get Deep Sky Stacker, it's free. So get started with that. And then to polish it, I used Paint Shop Pro CS6. But that's what I took to get this picture. I also did some cheating. I say an APO refractor, but why is it that I've got these hash marks there? Anybody know?
Diffraction spikes?
Yeah, why do I have diffraction spikes, Bob? No. So what you can do is you can take a piece of string and make an X in front of your scope to actually get those diffraction spikes. Now, this will be the last major slide. I promised Alan that I was not going to get into post-processing. I'm leaving that to Kevin Quinn. But this is just to explain to you what these light frames are, and all I want you to do is just to take them. Do not give a clue, don't give a care what you need them yet for, because Kevin Quinn's going to explain to you why you need them later, okay? But your light frame, when you hear about this, so when I was reading my first books, it says, take like 21 plus light frames. I'm like, well, what's a light frame? Bob, what's a light frame? He says, well, that's the picture you're taking. I go, okay, good, all right? So that's the object I'm taking. A dark frame is an image taken at the same ISO, exposure time, and under the same environmental conditions as your light frames, but with the lens cap on. And of course, I've got the table here. So cap on and off, dark frame on. Okay, because those are questions people always ask me. And they are used to subtract the thermal and random noise from your light frame. And then I talk a little bit more, but there gets to be a point of diminishing returns. So I have how many do I have here? I said about 16 plus. If you have time, so it will improve your thermal noise reduction by a factor of 4 with 16 dark frames, okay? But then to improve it a little bit more by 5, you gotta take 25 dark frames. If you wanna do it by 6, you gotta take 36. You're gonna be out there all night? So you reach a point and go, I think I can handle 16. That's what I can mentally handle. A flat frame is an image taken at the same focus, camera orientation, and optical setup as your lights. Do not remove your camera from the telescope, because what you're going to do with these is that removes all the imperfections that are created by your lens, smudges, the dust donuts, insects, things like that, that get into your lens. And you take those against a white neutral background, which could be a computer screen or a white t-shirt that's covered over your telescope. If you're interested, I'll talk to you more about it later after this. I just want to get the points across, or you could take a picture. A bias frame is taking it does not have to be at the same ISO. Some people would argue it doesn't have to be. I just say, why change it? There's no reason to change it. Just keep it the same. But at the highest shutter speed, for DSLRs, it's usually between 1 to 4,000 and 1 to 8,000ths of a second. You're not really caring about the exposure. What you're caring about is the readout signal from the chip that you're then also trying to remove from that image. So you're taking out the thermal noise, the readout noise, and like I said, the least amount of vibration, and that's what it all takes to take a great shot. Dark flat frames, you don't really need to care about its exposure the same light as your flat frame, but with the telescope covered up, it reduces the noise from the flat frames. But with cameras today, and because your flat frames are so fast, you probably don't need to remove noise, and I think your bias is probably good enough, unless somebody wants to argue or if they got a good point. Alan or anybody?
I have used bias and dark flat frames for a long time. You know, cool sensors don't really kind of need it.
Yeah. Is it CCD?
Yep.
Yeah, so it's with CCD, you just really don't. I mean, unless it's like hot and humid or something, but even then, yeah. So this is mainly for DSLR, but I would still say that because bias frames are only 1 to 4 thousandths or 1/8 thousandths of a second, just take your camera and set it to 1/8 thousand. I just took 10 of them and I'm done. So why not do it, right? It doesn't hurt. If anything, it improves it by just a little bit. It's a mental thing.
The reason to do it the same ISO is the discussion that we had in follow-up to Euro. If your camera does something different between the amplifier gain and the digital gain,
Hmm?
by setting the same ISO, you know you're using the same amplifier.
Gotcha.
So you'll get the same amplifier readout.
Yeah.
So that's a reason. And the other is, as you said, there's not a good reason to change it. Why change it?
Yeah.
Keep as much the same as possible.
Yeah.
For all your calibrations.
Thank you. That's a good point.
Go ahead.
What was the difference between the dark frame and the flat frame? In the dark frame, you had your cap on, you were taking a same exposure, same picture.
Yeah.
And the flat frame was, you said something about a white t-shirt or something?
Yeah, so it's back here. So what happens is you take a picture, so you put a telescope over the aperture of your telescope, you point it to a blank spot in the sky. Some people have these boxes, these white, have you ever seen those white light boxes? It doesn't matter. But there's different ways to get white frames. So all you want to do is so if this screen was all white, it was a TV or a computer screen, and you just made it white. You take a picture of that, but what's being captured in there are all the smudges, the light deviations, okay? And then what happens is that's applied to your light frame, and it removes the light deviation so that it becomes a flat field, and it removes the vignetting. Like, let's just say, for example, you take a picture of an object that's above a city, but when you look at your light frame or of your target, you're going to have your target, but it's going to be like lighter gray hair and like darker black hair. If you take that flat frame, the way I describe it here, and you run across it, it'll turn it all evenly black. Okay.
Totally, just to clarify. The dark frame, you have no signal from the outside.
Right.
The flat frame, you have signal.
You have white signal
Yeah,
coming
yeah,
in,
you-
right?
Yeah.
The intent is to have a perfectly uniform white illumination that
Okay.
you then sense with your system. There could be smudges on your lens, there could be vignetting on the edges of your field, and that's the purpose of the flat frame, to subtract that out or actually divide that out. It's actually doing division.
Yeah.
It's important that the flat frame be entirely out of focus. Whatever you're looking at, whatever the source of that is, like you're saying a white t-shirt on the front, it's as far out of focus as possible, so you're not imaging the t-shirt.
Right.
You
You're
just want
imaging
a whole
white.
bunch of light flooding in, and seeing what the optics and the CCD does to uniform light.
So out of focus, that's a good thing.
Yeah.
Whereas the dark is measuring primarily the thermal noise from its no bias, but the thermal buildup that's keeping the readout from the chip not zero. Even if there's no light, what would you get as the numerical value for each pixel? You did this under the same temperature conditions as your light.
Yeah, that's all in the writing here. I just didn't want to read it to you to drive you nuts, but it's all in the writing, and that's when you do it. The reason you want to take the dark frame shortly after your light frames, after you target your image, because it's under the same conditions, and so the heat and the thermal noise is going to be the same. So, for example, when I took my darks last night, so I took my lights of an object, but it was damp. The temperature was, I don't know, 70, 50? It was about 50. I wasn't out there in the 60s, right? So it was damp in the 60s and this, that, and the other. And so when I took my darks with the cap on, they were under the same conditions to get the same kind of noise, okay? if I went into my house, so if you may get it for the rest of the people then. So,
But now, my question is on the flat front, the white t-shirt.
yeah.
White is dark. So
Well, yeah,
here, white
for
t-shirt.
example, take the flat frame
Oh, but you don't do it at
before
night.
the sun goes down, leave your camera on.
Oh yeah, so that's actually in here, and point to a clear spot of the sky during the day. I just didn't read that all to you, but I was going to save you from it.
Leave your camera on.
Oh yeah, you don't move it. You just leave it on all night, and when the sun comes up in the morning, don't get breakfast yet. Just throw a white T-shirt on it, and start to take these pictures. You want to set your camera to AV mode, and you also here is where there might be some argument, and oh boy, some will say that. Do you remember when I showed you the histogram? Okay. Things that I've read and things that I've seen online said that your white frame, after you take it, should just be between a third to a halfway. Some people believe it's, I think you do, it should be more. Okay, so let's just say, but you still don't want to overexpose. You want it someplace in the middle. But what you're going to find out is it's daylight, right? It's not nighttime, so my exposure is not going to be for 5 minutes. You're going to find out that your exposure is for 1 second. Right? And so you want to keep moving that until you go, and then once you get like where it's right in the middle, then you take about, nine plus of those, and then they get averaged.
So don't just go and do it and say, well, that's white.
Oh, no, you want the histogram. You do not,
No totally white pixels and no totally black pixels.
that's important. So it would be totally black if that histogram was all the way at the left, remember I was showing you that, or if it was all the way on the right, then it's overexposed, and that's why you want someplace in the middle. Bob?
A question relative to when to take darks. Another good time to take darks. You're out imaging and the clouds come overhead, you believe that they're going to go away after a while. Put your lens cap on, take your darks then. Right in the middle of your exposure run, just try to be opposite.
Yeah.
Take advantage of that time.
Okay, so I made a promise to Alan I wasn't going to get into processing, which I did the last time. But I wanted to get you started, and just to know enough that I'm going to go out, and you may want to take I'm going to take some light, some dark, some flags, according to the numbers. I don't know what to do with them yet, so most of you do. But those that I don't know what to do with them yet, go to Kevin Quinn's at 1:30, and he'll show you how to turn your pictures into wonderful, like Hubble-like pictures, based on these types of things. And with that, ladies and gentlemen, so this is just really quick. This is the last slide. If you wanted to take a picture like this, like you see here, this is what you're going to need. You're going to probably need an equatorial mount or a fork with a wedge, but you need something that's equatorial, probably the best. You need a guide scope, which is right here, and an auto guider. I don't have mine mounted, but it's a smaller camera that goes right here, and it sends signals to the mount to make minute adjustments for your target. So if you're going to image a nebula, you point at the nebula with the smaller scope. You focus on a star that's in the nebula, and the auto guider will track that star, and if there's any drift, it sends computations to the mount to bring it back. And you get sub-pixel corrections to your mount so that you can stay on target for 2 hours if you want to. Okay, it's pretty impressive. You want a modified DSLR camera that's remember I said you get rid of the filters so that you can get the light that comes from deep space objects, or a high-res mono CCD camera with a color filter works well. Imaging scope 3 to 6 inches, like I mentioned. Something with a speed of f7 or less. If it's f10, f9, it means it's a longer focal length. But what happens is this. It's great for more magnification, but when you do that, it takes longer to image something. So something at f7, it might take 5 minutes to image, but if you put an f12 scope on there, it might goes from 5 minutes, I'm just spitballing here, like 5 minutes to 10 minutes. So the faster your scope, the quicker you get a picture. Remote timer switch, we already know that. Photoshop or comparable, it doesn't have to be Photoshop, just a comparable program. Extra batteries and power supplies. You don't want to come out here and you were cheap and you didn't want to spend $6 more for more batteries, and then you're stuck because everything failed because you don't have your batteries. You want batteries for your camera, for and stuff that uses, I guess anything that uses batteries. Eventually, you're going to need a field flattener, chroma corrector, or a focal reducer, and you'll learn why later on. Filters, the standard ones. If you're thinking, I want to do deep space imaging, and there's all these filters out there. Which ones do I get? Okay, and I can tell you right now, a majority of space objects produce light in frequencies that we call hydrogen alpha, hydrogen beta, oxygen 3, and sulfur 2. And as a matter of fact, when the Hubble takes pictures, it has a camera that uses these filters. So you can actually produce some pictures that kind of look Hubble. In fact, that one right there this one right here looks like it was done in what's called a Hubble palette. You need a dew heater. We now know why. We got to keep the, right. So I wasn't kidding you there. But that's what you're going to need to get started in the real deep space stuff. And that's it. I think, Mr. Troy?
Yes, once again, the smartphone app camera that you were recommending.
Yeah.
Which one's the one
I think there's something called Camera LV Lite and Camera 360 HD. And you don't have to use those. You just do a search on turn my smartphone into a DSLR. And then there's apps. There's a whole bunch of them. Some you pay for, some are free. In the back?
When you're photographing the moon and you're focusing, can you still focus on the star, or is the moon so close you actually have to worry about it?
So it's near infinity, it's not at infinity, you're still getting some scrambled light. So if your lens is powerful enough, you can use autofocus and it'll solve it for you. But if it's not powerful enough and it may not be gathering enough light, then you just got to do manual focus and you just have to eyeball it. Yeah.
That's close enough to answer.
Yes.
I mean, terrestrial, after a few miles, infinity is,
Yeah.
Everything's not a crystal sphere anyway, so.
yes, pretty much.
Any SLR with an attached lens will autofocus on the moon because the contrast is so great between dark and light.
Okay.
But if you're trying to image the moon, the planets, and you are doing live view focusing on it, you say, yeah, it's got it. Do it on the stars. That's lure over to the planet.
Yeah. In
When
front.
you talk about temperature, particularly in a DSLR, that shutter's open, the sensor's heating up.
Yes.
So when I take the dark,
Darks, yeah.
and we talked about ambient temperature, but what about the sensor temperature? How do I make sure I get dark to the same
When you take the same length of time.
the same?
So that you can remove.
Up in your image is also being built up in your photographs.
Okay, but let's say I take 15 lights, it's going to continue to heat up over that period of time, right?
Yeah.
Don't have enough separation between you.
You know what's going to happen is if your camera's been on at 5-minute intervals, I mean, it gets to a point that it just gets only so hot. I don't think it really gets any hotter. And even if it does, it's minute. But you also, this is where I'm not talking about the processing, but you're also doing averaging. So the software does averaging of your lights and averaging it, and then it starts to pull stuff out.
One of the things that's heating is an amplifier on the chip. And I believe in DSLRs, they even turn off that amplifier. So that's staying on all the time. If anything is warm in the corner of the amplifier, it's not much, but it's reaching a steady state. Now, I think some of the technical cameras, the advanced cameras designed for astrophotography, turn the amplifier off while you're integrating, and they only turn it on when you read it out. So you get a 5-minute exposure, and it's actually electronically dead. And then when you're done, it turns on the amplifier, reads it out. It doesn't stay on long enough to heat the chip,
Mm-hmm.
because those cameras generally are electronically cooled also, and they know you want to keep everything cold. So why put power on the chip if you're not doing it?
But for the other ones, if it's on all the time, you're gonna reach a state where
It's just the same temperature.
And you will find that the darks remove most of that noise. I don't have a problem.
When I stretch my darks, I always get a little amplifier noise in the lower left-hand corner. But that's why you take the darks, so I can switch back
Yeah.
to all my lights.
You know what's funny? So I promised I wasn't going to get into post-processing, but doing things like that, there's something called stretching the histogram, which Kevin will probably get into. But usually, so remember we looked at the histogram, but in front it's all the black and stuff like that. But there's always a slope with some noise, and so you can actually move the slider to cut some of that noise off, which already helps. So you subtract your darks from your lights, you get new pictures, and they're pretty good, but you could still pull a little bit more by stretching and then deleting some of the thermal noise that's at the beginning of your histogram. And you learn all those tricks. I'm just trying to spare the crowd from all that. But if I can get you started, that's good.
So a big source of heat on a DSLR is the display.
Yep.
So if you're trying to keep your camera cold, try not to be looking at the pictures right away, right?
Mhm.
That will heat up significantly. That's
Yeah,
a huge
yeah,
source of heat.
Right.
So
And then you're trying to focus on things using a DSLR and a lens for the nice big things. You focus on a bright star, you get that maximized. You'll see tiny faint group stars start showing up. Then you can fine tune on those, because if you try to just get a sweet spot on the big fat bright stars, you won't get a critical focus, but you can then focus on the fainter ones and get better from that.
With CCDs, I've been very useful to do that. A lot of the questions were rich
Hmm.
those are excellent place. Because you just the whole camera of the stars there.
Okay, any other questions? If not, I guess, John, you're probably willing to stick around and discuss your
sure.
setup a little bit. But in any case, let's thank John.
Thank you. Thank you. Thank you. Thank you. It's my honor. Thank you.